Hello, welcome back to More Fun Fixing It. My name's Lee, not Mark, as some of you have made that mistake at places where I've met you. Today I've got on the bench a ZX Spectrum, one of my old favourites. This one is a rubber key 48K ZX Spectrum issue 3B. This one's unusual in that the motherboard is this dark green colour. That's usually associated with the later boards that are made in Korea, the issue 4s and 6s. Maybe just the 4s, I can't remember. Oh, I'm trying to pull that out and there's still a screw in it. So as you see, I've already opened this up, so I've done some pre-examinations. I've had a little look at this, but I am just as in the dark as you so far. Just making sure there's no crack joints on the power socket. Right, so where do we start? I'm going to do, right, the last video I did, I went through all of the things that you should do before you switch on a ZX Spectrum. So this time, I'm going to do it the wrong way. Well, kind of the wrong way. This is just a shortcut way in that I'm going to switch it on with the Steam Card Pro attached and just see if the voltages are there and then take it from there. Before I go looking for resistances and things. So, oh, it's making a weird noise. Oh, it's not now. A couple of things I noticed there. All of the power lights are lit up, and that doesn't mean that they're all exactly as they should be. That's something I'll have to check manually, but there's no data bus activity at all. That's not good. That's not ideal. And it's trying to reset when I press the NMI button. Well, it resets when I press the reset button, but there's kind of activity there. Have I got a display? So as you can see, I've connected up my Henry Instant Composite mod. Okay, we've got yellow border and black and white stripes. Now we've got a black border and black and white stripes. And what about when I press the NMI button? Now I'm pressing the reset button. It's kind of the same sort of thing. All right, so the first thing to do is to rule out the ULA because it's the only one in a socket. So I don't have to take it out. I don't have to desolder it. So I'm just going to pop it out of here and plonk it in a different board that I know works and make sure that this is a good chip. It has got a tick on it, so I'm hopeful that this is something I've already tested. But that's not a guarantee. I want to take just a moment to talk about today's sponsor, PCBWay. This ZX Spectrum issue 3B is a shining example of how PCBWay is the perfect choice to get a destroyed, precious computer back up and running again. A quick search of their shared project library reveals that contributor Pab from Poland has generously shared a complete and accurate recreation of this very same ZX Spectrum motherboard revision. If your issue 3B has succumbed to the tender ministrations of a previous repair by a plumber, all you need to do is click Add to Cart, choose your finish and board colours, pay using a variety of methods, and very soon after, a box with some brand new motherboards will drop onto your doormat and scare the cat. That will just leave you the pleasure of removing the old bits from the broken board and installing them onto the new one. As a quick tip, it's also perfectly possible to go from any other revision, not quite including the 5 or 6, to this issue 3B with just a few slight component changes. Massive thanks to PCBWay for sponsoring this channel. Be sure to click the link in the description to check them out and get a £5 sign up bonus today. Cheers! Here's my stunt specky. It's an issue 2, but most ULAs work in most machines, so I'm pretty sure, well, I know that an issue, a -7 ULA like this one will work in an issue 2, no problem. There are certain combinations that don't work. So I'm going to have to connect this up like it's a, I don't want to change the lead, so I'm just going to connect this up like it's a non-composite modded machine. Clipping onto that lead down there. Like that. See if this turns on. It doesn't. Oh, that is a... If that's the ULA, then it's kind of game over. No, it's not the ULA. Why was that not working? Oh, it is working. Okay, so the ULA is okay. That's why it's got a tick on it. I'm not sure why that didn't fire up the first time. Might just, I don't know. This has been recapped in modern times, so I don't think it's like caps reforming or something like that. Might have just been a bad connection in the socket, maybe. Okay, so we can rule out the ULA. Let's just make sure that the socket is not going to be part of this equation by giving it a contact clean. Is it a dual wipe? Yeah, it's a dual wipe socket. They must have been feeling flush that day at the Sinclair factory. Where was this made? It was made in Korea. An issue 3 made in 3B made in Korea. That's quite interesting. I am suspecting the CPU at this point. Yeah. Okay. I think the next thing to do is turn on the oscilloscope and probe around on the edge connector connections on the Steam Card Pro and see if that is going to show us anything. I might have to compare to a working board for some of these, but yeah, clock. We should have clock because we've got a picture. So, and it's trying. There's something that's trying to run there. Let's try the other diagnostics. It could be ROM, could be CPU. CPU feels a bit warm, actually. CPU is quite warm. And you have the memory getting hot. No memory's getting hot, and the only thing really getting warm on here. Oh, I do still need to check the voltages. And we've got 5 volts coming out of the voltage regulator. I'm going to awkwardly reach over here for the -5 is -5. That's perfect. +12 is +12. And 5. This has had the DC-DC mod done to it, which is really good. And it looks, these caps are often fine. I don't think I've ever had to recap a board with these caps in. So the fact it's got the composite, no, the DC-DC mod done means that the voltages should be nice and stable. Okay, so I've connected the oscilloscope ground lead to one of the ground clips on the Steam Card Pro. And the first thing I want to do is look for the clock. Yeah, it looks like we've got a good clock. I like the way that rose up. There's no contention going on there. Normally you'd see, I think you would see contention where there would be gaps in the clock. Reset, where is reset on here? Yeah, right, reset is there. Yeah, that's fine. It's a bit slow coming up, but then you would expect it to be okay after you press reset. It is quite slow coming up. I wonder if C27 is bad and then just holding it in reset for too long and messing things up. Let's try with an LCR meter. It doesn't give the best picture, but I can always pop one of the legs out to get a clearer picture. So it's a 1 microfarad cap, and it's measuring 1.158 microfarad at 27 ohms. Yeah, I think I'm just going to lift one of the legs up. and test it out of circuit. Just flow a little bit of solder onto this top side. Pop that out. It came out nice and easy. I was expecting that to put up a fight. Right, and outer circuit. Yeah, that's nothing wrong with that cap at all. 1.1 microfarad at just under 4 ohms. That is fine. I really honestly believe that the caps are, unless one's gone just bad, I don't think these ones are automatically something you should replace. They're not going to leak all over the place and destroy anything. But that reset, I don't know, something's holding that in reset or holding the reset down. Okay, I'm going through some of the address lines here. Oh, why is that shrinking? Oh, this actually could be that my scope, yeah, I think my scope is set wrong. Hang on a sec. Okay, yeah. Let's go back to the reset. I had my scope set to average. I don't know why it keeps resetting back to average, but it's really annoying. Right, so reset. No, that's a perfectly normal reset. Yeah. Okay, so reset looks good. Let's go back to the clock. Make sure that looks good. There's no contention there, so there's no activity. So address line 0, address line 1 is high, address line 2, nothing, address line 3. Do we get anything from reset? Oh, we get some activity if we reset. Okay, so address 0, 1, 2, 3. Video signal. Yeah, more video signals there. Bus request is just high. Right, A7, A6, A5, A4. Can't read that. ROM chip select is just high. Bus acknowledge is high. I don't think they should all be high. Address line 9, address line 11, address 10. What is that? 8. 8 looks weird. Is that going to come back to life if I reset it? Oh yeah, address line 8 looks very weird. Refresh. NMI, which is that one. Didn't do anything. Yeah, nothing's happening on the NMI when I press the NMI button, so I reckon this is CPU. So there are the 12 volts. Weight is high, -5 volts. Read write, or read, no, write that is, and read. Something IRQ, can't read that. I need some help. IORQ, and I think this is memory request. Halt is high. Doesn't that mean it's halted? What's halt is active low. So that's right, that's fine, I think. NMI is, haven't I? Oh no, it was, I didn't scope NMI earlier, that was M1. So this is NMI, so now that should, yeah, that goes low when I press that, so that's fine. Interrupt is doing that. Right, data lines, ooh, yay. That is not a healthy data line. No. All of the data lines. That's literally every data line looks horrible. Broken. But why? So it's not the ULA. I'm still leaning on the, if it was one data line broken, then we'd be looking at one of the RAM chips that would be pulling it down or messing up the data bus. But for all of them to look broken like this, literally every data line is a mess. There's a few more address lines there. There's data. data line 7 as well. A couple more address lines over there. So is that 14 and 12, +5, -5. Okay, with the CPU getting a bit warmer than the other chips, I suspect it's a Z80 CPU fault. That's my best guess. We've got voltages, we've got clock, we've got reset. We're missing everything off of the data bus over here, and what we can see on the actual scope, on scoping the actual data lines, it looks a real mess. Knowing that, I mean, the data lines come from everywhere. It could still be ROM, but I think the more likely thing is the Z80 CPU. That's gone pop. Yeah, let's do that. Let's take out the CPU, and I'll put it in my CPU tester, and we'll see if it's working. Oh, there's a bodge on the back here. That's on the other side from that. Those two rows of 3 there are the transistors. Well, there's a row of 4, TR4 and TR5. They must have lifted a trace or something when they were doing some work on this side. It's not the worst bodge. I will leave that intact. I'm not going to touch that. All right, let's try to take the right chip out this time, Lee. Let's not make any stupid mistakes. Or if I'm going to make a stupid mistake, at least make a new stupid mistake. All right, all these legs, ooh, I bent that too far. All these legs are slightly splayed out. So I'm just going to give them a little tweak back towards the center as I reflow them. Issue 3 boards always make me nervous. They're the ones that I've had the most problems with in the past, with pads lifting up. Oh, by the way, I'm visiting the National Museum of Computing at Bletchley on the 20th. There's a group of us going from the Retro Hardware Discord, and we're going to meet up there and just, you know, it's not an event, it's just a normal day, but there's a load of friends and associates of the Discord channel are going to meet up there and have some, you know, nice relaxed time. It's going to be a fun day. Let's get the heatsink out of the way. It's even got some thermal compound on this one. It's very unusual. Right, tweak the legs. Maybe. Yeah, one side seemed to come off better than the other. Or it's the solder removed better from one side than the other. Yeah, it's coming out. Just a wiggle. There we go. Z80 removed. Right, so rather than putting this in a tester, I'm actually going to connect it to, I'm going to install it in this board instead, because it will give me an instant picture of whether this is working or not. Should probably make a ZIF spectrum with the ULA, the CPU, the ROM, and a RAM chip maybe, and in ZIF sockets. Actually, I don't need to connect it to the power supply, to the display. I can just stick this in, and we'll see if the data bus is. No, it's not. No data bus. I bet it's got the same issue with black and white stripes on the screen. Switched on. Yeah. Well, it's trying to run then. Okay. CPU's bad. I recently bought a whole batch of Z80 CPUs from AliExpress, and here are some of those. And they were sold as modern ones. So what is the date code on these? It says 1834. So I don't know what that is. 2030. These are from the future, basically. And they were sold as CMOS, but they are actually, or some of them are NMOS. I can't remember which ones are which. I don't think I marked them. But the thing is, you kind of want an NMOS in a ZX Spectrum. So I'm happy to put one of these in here. That's my board. Let's just make sure this works actually. Yeah, that's running. Let's give this one its CPU back. Get back in your corner, you. Okay, let's see if it works now. I think it's going to work. I think that looking at the rest of the chips on here, I don't see anything that's unreliable, apart from obviously a ULA that could be seen as unreliable. But I think that this is going to be the end of this one. I'm not going to put a heatsink on the voltage regulator yet. I'm just going to see if this fires up first. If I get beep, 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 then I'll put the voltage, the heatsink on. Are we ready? Steady, go. Power supply's not on. Ready, steady, go. Yes, beep, beep, beep. Right, so now I can put the voltage regulator's heatsink on and run the full tests. Horrible display, but oh, that's better. Just need to clean that socket up. That's just, yeah, that's why that's looking so manky. Keep my finger on it. And done. That's working. Right, so I'll do a quick composite mod. Then we can test the... Oh, the keyboard's got a new membrane. Keyboard's got a brand new membrane, so I get to play some... Well, not... Actually, I don't know if that is brand new. I get to play some Manic Miner. This would be a good one to own, this one. It's... I'm not at all worried about these capacitors. They'll probably last another 10 years, no problem at all. The voltages are nice and stable. It's got a lovely new keyboard membrane in it. The ULA is a -7, so that's really good. Yeah, I don't see this one being a problem for anyone in the future. So I'm going to button this one up, plug it in, and play a bit of Manic Miner. It turns on. Yep. Video connection is good now. Ah. Beautiful dulcet tones of Manic Miner. Oh, I'm on for a speed run. Oh my! Oh, oh, oof. I'm looking up directly into... Oh, I had to chicken out of it. I'm looking into a studio light up here. It's really, you know, and other excuses. It's on OBS. It's a new game to me. Never played this before. Didn't time this one very well. Oh, for goodness sake. All right, I'm not going to say it, but it is a stupid game. Right, that's it for this one. That was just a bad CPU. Actually, before we go, what does this do in the CPU tester? Ah, the CPU tester. I can never remember what voltage this needs. I think it's 5 volts. 5 volts. And I think it's center positive. So just change that. Yeah. Wrong way around. Okay. It's not happy. Mind you, that is on maximum speed, so I'll put it back down to the lowest and see if it's... What on earth? That is testing good. Ah, got to D6 and then stopped. Interesting, and then rebooted. So 1, 2, 3, 4, 5. It doesn't want to do anything on data line 6. So yeah, it looks like we've got a bad data line. That's quite interesting. Ha! There we go. One bad chip is all it was. Okay, that's it. Thanks for watching. I'll see you in the next one. Bye. One bad chip. It's not a hot chip, it's just a bad chip.